The following guidelines give us a step-by-step procedure for writing a proof by mathematical induction. So the very first step is to write out exactly what you're trying to prove. So in particular, for all n greater than or equal to b, the property of the natural numbers we're trying to show for a fixed integer b, which may be 1 or may be a larger integer. So in this case, note that p of n is standing for a generic property, but within the particular application of mathematical induction you are trying to do, ensure that, so the particular property you're trying to prove, ensure that you actually write out what this property is. So I don't want to see this specific statement. I want you to interpret what the property is that you're trying to prove, because this will help you to determine exactly what it is you're trying to do and allow you to do so. Okay, so then we're going to prove this statement by mathematical induction. So we begin with the basis step. So you would write out the words basis step and then proceed to prove the property for the first integer b that it applies to. So it could be that you're going to prove the property for 1, or it may be a larger integer in which is the first integer in which the property holds. Okay, so that will complete the basis step. So you'll write out a proof for this first integer, and then we'll move on to the inductive step. So the first thing to do is write the words inductive step. Then you're going to state and clearly identify the induction hypothesis. So you're going to write, assume that p of k is true for an arbitrary fixed integer k greater than or equal to b. Remembering that p of k is a generic property within these guidelines, but you should always interpret what p of k is. So for example, suppose that we're trying to show the property, to prove the property that the sum of the first n integers is equal to a particular formula. So then in this case, you would assume that the sum of the first k integers, so replacing n in our general property by k, so 1 plus 2 plus k, is equal to the particular formula given to you, but replacing every instance of n by k. So you would want to write that completely out because you're going to want to use that equality in your inductive step. So after you've written out your induction hypothesis, then you're going to proceed to prove the property for the next integer, so for k plus 1. So in order to help you in doing this, you need to write out exactly what the property is for k plus 1. So in the case of the example, where we're talking about proving the sum of the first n integers is equal to a particular formula, we would write out the sum of the first k plus 1 integers. So 1 plus 2 plus k plus 1 is equal to the formula given to us, but replacing every instance of n by k plus 1. Okay, so that tells you what it is you're trying to prove. In the case that this is an equality, as in our example, you would work to prove it looking at the left side and the right side of the equality and working through that. So in our particular example, we would look at the left side, which is the sum of the first k plus 1 integers, and then we would want to use this equality that we know what the sum of the first k integers is. So replace 1 plus 2 plus k by the formula given to us in the induction hypothesis, and then working through the algebra to show that that is equal to the right side of the formula we're trying to prove. So once you have proved the equality, inequality, or various properties that you're being asked to prove for k plus 1, then you will identify the conclusion of the inductive step by simply saying that this completes the inductive step. As soon as you have proved the property for k plus 1, using the induction hypothesis, you have completed the inductive step. And finally, we end in a proof by mathematical induction by stating a conclusion, namely, by mathematical induction, the property p of n, which you will interpret given the particular application you're asked to do, is true for all integers n with n greater than or equal to b, where b is the very first integer in which the property holds and is the integer you proved in the basis step. So hopefully that gives you a concrete step-by-step process for proving properties by mathematical induction, and I urge you to keep this slide to help you and guide you through your proofs, ensuring that you always interpret the property given your particular instance or question that you're trying to prove. Make sure you always use the induction hypothesis in your proof of the property for k plus 1, and writing out at each step what it is you're actually being asked to prove by interpreting the property at each step for each different integer will be very helpful.